Good evening, students. Have a look at this question. One is a double sigma. I is lying between j to n, j is also lying between j to n, but I is always less than equal to j. N choose I, n choose j. That comes out to be, I'll show how, 4 raised to n plus 2n cn by 2, and a single sigma, which is basically 2n choose r from 0 to n. Incidentally, this also comes to the same value 4 raised to n plus 2n cn by 2. Now the question here is whether this is a matter of chance or a matter of fact. If it is a matter of fact, then I should be able to connect these two directly as equal without even knowing the value that it is 4 raised to n plus 2n cn by 2. So first what I'll do is I'll prove the left one, then the right one, and then probably directly without knowing the values. In order to prove this n choose I, n choose j, I first remove the restriction I is less than equal to j. That means I take I and j as independent, and I realize that this comes out to be n choose 0, n choose 1 plus n choose 0, 0, n choose 1 up to so on nc0, ncn. This is basically I have expanded j keeping I as 0. Additionally, keeping I as 1, I take again j from 0 to n, so that makes it nc0, nc1, nc1, and so on nc1, ncn. And likewise, now I keep on changing the values of I till I reach ncn, nc0 plus ncn, nc1 plus up to so on ncn, ncn. So this should be basically 1. Now if you look at this entire sum, this is basically 2 raised to n multiplied by 2 raised to n, that is 4 raised to n. So the elementary of summation, you know that this total sum is 4 raised to n, of which I is equal to j appears on the diagonal. That means above the diagonal and below the diagonal, at one side I is less than j and the other side I is bigger than j. By symmetry, since they both are same, I assume the diagonal sum to be b, one of these sums to be a, so by symmetry the other is also a. So I realize that a plus b, the total sum is 4 to the power n. Now if somehow I add another b to this, so that will make it 4 raised to n plus b, and b is nothing but summation c naught square c1 square up to cn square, that is 2n cn, that is a plus b. And in the left hand summation, I am expected to go from I 0 to n, but I is less than or equal to j, that means a plus b. So if I see a plus b, that comes out to be 4 raised to n plus 2n cn whole divided by 2. So the left part is obtained as the desired result. Now let's quickly look at the right one, and then we will ignore all this and equate them directly. 2nCr, so if I take 2nc0, 2nc1, 2n choose 2, up to so on till the last one, which is not n, which is actually 2nc2n. So with the theories of all possible selection, this basically is 4 to the power n. Now from 0 to 2n, we very well understand that the number of terms are 2n plus 1, which is odd. That means there would be a single term which is in the middle, which is 2n choose n, and the rest of the terms on the left and right, they both are equal because 2ncr is 2nc 2n minus r. Again, there is a single term which is lone. So if I add 2n cn on both sides, this will become double. And from 0 to n, actually, I want to add this thing. So very evidently, this sum also comes as 4 raised to n plus 2n cn, the middle term added, and half of it. So this is why they both are equal. Now the big question is, can we equate them without knowing their true values, that is 4 raised to n, 2n cn by 2? If yes, then it obviously becomes a matter of fact that even without even knowing the values, we know. For this, I take a small storyboarding something whereby we use the entire expression on the left hand side or the right hand side, which is a binomial or a combinatorial expression representing some counting, and if I can equate both these counting to the same value, we are done. So now I assume, let us say we assume there is a school which has n boys and n girls, equal number of boys and girls in the school, and somebody asks me to select certain number of boys, say I, and certain number of girls, say J, subject to condition that the number of boys is always less than or equal to the number of girls. So that basically is my left hand side. Select I boys, choose I boys and J girls, but ensure that the number of boys is essentially less than or equal to the number of girls. I don't know, I don't really want to know this value, but can I equate that the number of ways in which this selection can be done is as good as the number of ways which is represented in the right hand side? What is the right hand side? Right hand side is among these two n students, you choose R students. What is R? Half or less than half, because your R starts from 0 and goes up to n. So if I choose half or less than half students from the entire class, the number of ways of doing this, the number of ways of doing this is exactly same as the number of ways of choosing certain number of boys and certain number of girls, ensuring that the number of boys is less than equal to girls. If I can justify these counting to be the same, the result is done, and this can be pretty easily done. All you need to do is whatever you have chosen as a number of half or less than from the entire pool, those are students, ask them to go in room number 1. I'm talking about those are students whom you have chosen half or less than half out of the 2n pool, and remaining 2n minus r, tell them to go to the room number 2. Isn't this as good as simple as choosing r students out of 2n who go to room number 1? Obviously the remaining go to room number 2, and you see the magic. There would be certain number of boys and certain number of girls in room 1. There would be certain number of boys and certain number of girls in room 2. Irrespective of what, one of the rooms definitely will have the number of boys less than the number of girls, or both will have equal, because the total number of boys and total number of girls are same. So it will never happen both the rooms will have bigger number of boys than the girls. So either they are equal, or on one of the room the number of boys is less than the number of girls. You have to just tick that room every time that this is your room. Say for example, I take k boys in room 1. So r minus k is definitely the number of girls because the total count is this. So n minus k boys in room number 2 because the total count is n. So obviously n minus r plus k girls in room number 2. In one of these rooms, either this way or this way, the number of boys is less than equal to the number of girls. If they are both equal, then also you are done, and otherwise you have to only tick the room where the number of boys is less than number of girls. So obviously the total number of ways in which these 2n kids can be divided into 2 rooms, and I tick the right room to get the number of boys less than the number of girls or equal, should be evidently equal to this counting. Hence they both are equal, and obviously it's a matter of fact. I might not know this value, even these, then these two are equal. Thank you.